Right, are we ready? Ooh, we are live. Cool. Right. So, welcome everyone. Keith is here from Red Hat, and I'm Andy from Starburst. We're going to be talking about building scalable data products to fuel data science outcomes, which is a rather long title. And given that this is the data science theatre, I'm assuming everyone here is pretty intelligent. So if there are questions, and I'm sure there will be, I think we probably want to do them at the end, but we will probably run over. And if we do, please come and visit us at the booth over there. We'll be on the Starburst booth, and happy to have discussions, arguments, debates, whatever you guys want to do. So before we begin, I'm going to put up what looks like a rather simple slide. And when I think about data science, I think about this life cycle. And I think about, actually, there's broadly 3 steps. When we're doing data science, there are 3 things that we want to do. We want to discover data, we want to develop some sort of analytical model, and then we want to deploy that model. And if we think about those in a bit more detail, data discovery is really an activity that data scientists have to do to figure out what data is where in an environment. And that sounds easy, but actually, in my experience, it's not. Typically, we have data in our environments in, let's say, an on-premise Oracle system, maybe on-premise Hadoop, maybe we have some data in Teradata, maybe we have some data that's also in the cloud, maybe it's in an object store, maybe it's in multiple object stores across multiple clouds. Maybe the definition is bad, maybe we don't have a data catalog. In any case, what we see in large organizations that have been around for a while, is, and I'm not joking, but I regularly see this situation where someone is essentially a data scientist walking around with a piece of paper asking a DBA or an admin of data or a data owner, data steward, whatever, what data they've got, where it is, how can they get access to it, what are the credentials, etc., etc. And so this leads into this kind of analyst research idea. People like Gartner, McKinsey, and others have been purporting for many years that actually this initial process takes anywhere between sort of 50 and 70% of the time of a data scientist. And I would suggest that having someone like yourselves walking around an organization asking people can they get access to some data, or emailing people and hoping for a response to get access to some data is probably not the best use of time. But that's where a lot of time is spent. Once this data discovery process is sort of finished and we have an idea about this data and we have some access to this data and perhaps we've run some correlations and maybe some aggregations, joined some data from different platforms, and we figure out actually we have something that looks like what I call an analytical base table. I think people call it feature stores nowadays. But some data that we think is relevant to answering the problem that we were originally given, then we move into that model development phase. And the likelihood is that we've spent so long discovering data, we have very little time to kind of play with the data and apply the various statistical algorithms or routines to that data to look for trends and patterns that then lead us to be able to answer a question. And so that to me is what model development is. It's a very high value activity, but it's an activity that I'd argue we don't spend enough time on because we've had to spend that time on the data discovery. And then once we've built our model, the output of that could be essentially a series of rules and a series of thresholds. So, if a particular, maybe we classify customers in some ways, so if we've got a customer that lives in a house and has a cat and, runs or something, then maybe they're likely to buy our product or they're likely to churn from our service or whatever it is. But we can start to see that typically that is a series of rules that we may want to apply to new data. And this is where we get into model deployment. And again, there's various approaches to this. We can apply that to new data as it arrives, or we can apply that to maybe our entire customer base, to score individuals, whatever that may be. Ultimately, we want that data, though, those scores or those propensities to do things, we want that in front of someone who can make a decision and someone who can then take a better action than we would have done otherwise. because otherwise we've just spent all that time and money on infrastructure and computers and effort for no reason at all. So that model deployment, I'd argue, is really important. From a data science point of view, I would say that actually it shouldn't be their job. Build the model, give that to maybe a data engineering function, and actually it's low value from a data science perspective. But it's very important. And that's kind of how I think about sort of the data science lifecycle. And I break it down like that because that's kind of how we're going to break down kind of the rest of the presentation. So, and I'm also a relatively simple man. And putting things into 3 makes sense. So, I want to just introduce you a little bit to Starburst and how Starburst can kind of help that process. So, for those that aren't aware, Starburst is a technology built on an open source engine called Trino, originally developed at Facebook to enable thousands of end users to run queries across multiple petabytes of data. I think Facebook have about 300 or 400 petabytes of data. And the open source technology is used by the likes of Uber and LinkedIn, Netflix, etc. And the idea here is that as a data scientist, I can send a SQL query into an engine, and I don't care, and nor should I, where that data resides, or whether that's a technology platform or whether it's a geography. Right, so I am now decoupling myself from walking around with a bit of paper and asking people. I can just access those systems in a very fast, very performant manner, whether that data is in something like Iceberg or Hoodie, whether it's on S3 or ADLS, a combination of all of those, or it's on-prem in Oracle or Teradata, or it's in a different country. As a data scientist, I shouldn't care, right? I should be able to just run my queries in a governed and controlled way. And so you could hopefully start to see that from that data science lifecycle perspective, Starburst can help us accelerate that data discovery process. And then the output of this process, I would suggest, is a data product. I will not get into the definition of a data product. I've got another session later on where I'm going to just get into data products, and the people in the audience will probably have a massive argument with me, and that'll be fun. But for the purposes of this session, we can imagine that we are going to build a data product very quickly, without caring where the data is, for end users, for the next step in the data science lifecycle very quickly. And just to give you a kind of a flavour, and again, this isn't meant to be a sales pitch, but just to give you a flavour of kind of where Starburst is used, we see organisations in financial services doing things like fraud management, risk management, anti-money laundering, exercises where we want to view across a lot of data in a lot of different places, and we want to understand perhaps customer behaviour. We want to be able to do that very quickly. In the case of fraud, fraudsters have this habit of changing behaviour very often, and so we want to be able to access new data very regularly to update our models, to make our models, make sure our models kind of keep up with what the fraudsters are doing. I'll just mention healthcare and life care, and healthcare and life sciences, and then move on because of time. So we see quite a lot of use of this ability to access data in different places in that arena as well, because actually what we may want to do is look at data across geographies, and that data is very sensitive. Typically, we are looking at patient data, and so having a system that allows us to run queries, keeping the data in location, but still getting results and still being able to use that as part of our data life cycle is sort of core to the process. So I'm going to switch over to Keith, who will start talking us through the model development process.
Hi, can you hear me? Okay, great, thanks. So, audience participation. Who has heard of OpenShift? Raise your hands. Excellent. Not too many. What about containers? Do you use containers in your day-to-day business? Excellent. Okay. So, Red Hat OpenShift AI. It's a new name, and it's for a portfolio of products. So if you are familiar with OpenShift, it's an enterprise container platform. And if you've been to all of the events today and yesterday, they are talking about AI, ML, big data. Most of the data scientists will run this workload in containers. Red Hat is open source, So we take upstream products and we bring it to a downstream. We enterprise ready and put a support contract around that. And so our mission is to make the data scientists' work much easier so they can go through the process that Andy's just talked through. So it's a platform, as I said before. It gives you the ability to do model development, so we can share those models as data scientists with our colleagues. We can do model serving, so we can produce the models, we train the models, and we can produce them as an end result to the business. We can also do life cycle management, so therefore we can actually go through debugging, retraining the models, things like that, and we can share them across. If it's on-prem and you want to burst it into a cloud, we can do that as well. So why containers? If you are familiar with containers, you know that they are easily packaged. They can have resources built into the actual container. They're very portable. They're very scalable. They're very reliable. And as I was saying before, the data scientists want to use containers because it makes their work so much quicker, and the end result is to get the model out as quick as they can, so it's good for the organization. So Kubernetes is an orchestration engine, as you probably know. It's great. It brings some fantastic features to containers. It can give you scaling. It can give you self-healing, and it can give you much more other things for the containers that you could do if it was just basic. So it's a real orchestration engine. What OpenShift does, it builds on top of that. So if you, as a data scientist, want to have GPU support and you want to share those across workloads or share them with your colleagues, you can do that. You have the ability to have more security built on top of that. And also you have a very nice web-based UI, because not everyone likes working from the command line. So OpenShift Data Science sits on top of OpenShift. It runs everywhere that OpenShift runs. So at the bottom, we can see if we want some hardware accelerators, we have NVIDIA support and Intel, for NLP or foundation modeling. The products that are in OpenShift Data Science is this thing that we will see in the demo later on. It's the ability to take your models and run them through a pipeline. So very similar to upstream Kubeflow, if you're familiar with that. We have, for the data scientists, they are able to develop their models inside Jupyter notebooks, which is pretty standard. We have PyTorch and TensorFlow support. And this model serving, as I was saying, and you will see it in the demo, is the ability to take your model and give it like an HTTP request so you can actually consume that model as an end user. We obviously have got support all the way up the stack, and of course we're talking about Starburst today, and you'll see that in the demo as well. And you can go all the way up the stack to essentially what we are trying to achieve for the data scientists is this: develop the model, deploy it, and monitor it. So with that, we are now going to shift gears into a demo. Now, I can't do the demo because there's no keyboard here, so we're going to see a recording that I have done, and hopefully it will run. Obviously, we didn't want to do it live because the internet here is not very good. So I'm hoping it's now going to start to run. Essentially, this is the fraud detection demo that we're going to look at today with Starburst and Red Hat OpenShift Data Science. So here, you will see OpenShift Data Science at the top, and at the bottom, when we go through the demo, you'll see Starburst, and we will see some artifacts, some data that we're going to use for our demo. So this is going to be our credit card fraud transaction data. we're also going to train the model, and we're going to have that in a Google Sheet. We are going to produce some products, data products from this, and then we're going to consume that inside OpenShift Data Science. We'll do some experimentation. We will run it through the pipelines, and you'll see that in the demo. So we can then do some offline scoring. So we want to be able to take that data, train it, and ultimately the end result will be that we are going to consume this model scoring artifact and then give that to the model serving. And the model serving will be simply, I will go through the demo and do an HTTP request to look at some live data to see if that data is fraudulent or not. So with that, we should be able to go now into the Starburst UI. And here we have set up an instance of Starburst. The two bits of data we're looking at is the training data, which is in an Excel spreadsheet, and that gives us the ability to train the model. We also have some data that's in an S3 bucket. In this case here, I'm using Mini.io, but you can use any object storage. And we were talking about data products a little while ago. So these are the data products. I've got transactional data, which is essentially the credit card data, thousands and thousands of rows. And we're going to look at that, and we are going to also train the model with the transaction labels, which essentially is telling me whether this data is fraudulent or not. And we actually want to consume that. The output of it is going to be transactional live data. So as I was saying, when we get to the model serving point, I can actually look at the data after it's been trained and see whether it's fraudulent or not. So it's ones or zeros. Yes, it is. No, it's not. Here, we can just dig into the actual data. I'm sorry that the resolution is not fantastic there, but these are columns or metadata of that transaction data, and we're going to use that in the next stage. So from here, we're going to jump into the OpenShift Data Science console, and we have the fraud detection project. A project allows me to share my work with my colleagues, so other data scientists, and we create what's called a workbench, and the workbench is my area that I can work on. And within this workbench, I have some resources at my disposal. The cluster storage is essentially persistent storage that I'm going to be giving to my container, which is essentially going to run my project. So if the container died and came back up, I've persisted that data. You'll also see data connections, and data connections allows me to set up some S3 buckets where I want to, as a result of model training, put that data into an S3 bucket so I can then consume it. In this case here, we're using Mini.io. So I'm now going to launch my project, which is essentially going to take me into Jupyter Notebook. I can get in there if I'm allowed, because we use rollback access and things like that. And you can see here we've got a project with using the notebooks. But if I want to actually bring in using Git, I can do that quite easily, go to a Git repo, so I'm able to share data with my colleagues. So whatever I do here, I can package it up and send it up into Git. As we step through this particular notebook, what we see here is some libraries that we need to bring in, but as I've already set this up in the workbench, we don't need to do that. And from here, you'll start to see where we are using some username and password to be able to log into the Starburst instance. And I've set these up in my workbench because I don't want to actually explicitly show that kind of secretive information. So that's very important to be able to do that. And so from here, I'm able now to talk to the SQL instance. As we go further down the notebook, which we'll be getting down into the next part, we can see where we had those tables before. So this is the data where I'm now going to connect to the Starburst instance. So as a data scientist, this is very easy. So I'm looking at the columns of the, the credit card fraud data. And I'm also going to look at the label data. This is the data in the Google Sheet. And what's really key here is that as a data scientist, I don't need to go off and find that data. I'm allowing Starburst to be able to stitch this data together, essentially using some SQL queries. So it treats it as an SQL frame, and I'm able then to let Starburst bring in the S3 data, which has got the fraudulent data. It's also able to bring in the label data, so I don't need to do that myself. I don't need to go off and get that data. It will automatically do it for me. So as a data scientist, I'm just running an SQL query. And then we will just run through these normal frames, these cells as we call them, and the output of that is I can see my data. I've got some metadata. It's got the labels here on the right-hand side, and again, apologies, you can't really see it. But as we run through to completion, it'll eventually tell me whether this is fraudulent or not. Now that's fantastic for a quick demo, but in the real world, if I have thousands and thousands of lines essentially in a Parquet file about credit cards, I want to be able to run these in a pipeline. And that means I can run them very quickly. I can bring in extra resources. I can run them in parallel. So what I'm going to do now is I'm going to set up this pipeline, and it's based on Elira. Elira is an upstream project, and it gives me the ability to stitch, essentially, some artifacts together, and I will have basically a blank canvas. So what you can see here is where I'm going to ingest my data. So this is credit card data. I'm going to do some pre-processing on that data. I'm going to then model that data. And what we're seeing here is that I can just literally drag and drop if I want to create this visual effect of creating this pipeline. So, as I say, we're going to go and pull this data in. We're going to process it. We're going to do some modeling on it. And then we're going to literally upload the output of that data into an S3 bucket. And then later on, I'll be able to look at that data offline, and we'll do some more modeling on it. So I've got some parameters here, which I'm just going to take the defaults, but that tells me how many times I'm going to run it. So it's how many epochs I'm going to run. And I will just let that run now. And from here, we can switch back to the OpenShift Data Science console. And now you'll see a very nice graphical view of actually that pipeline running. So it's starting to ingest the data. Starburst is going to stitch the fraudulent data with the labeled data, whether it's fraudulent or not. It's then going to pre-process that in this container that we're running. That's why we need persistent storage. And it's going to pre-process that, and it's going to put it through to the next part, which is the model development. And ultimately, we get to the very end, where it's doing this number crunching, and we are going to upload that data. And in my case, I'm just using Mini.io because it's an object piece of storage that's just easy to configure inside OpenShift, but you can use any object storage. So at the end of this, it will upload, and then we'll go into the Mini.io UI just to see where that piece of data has been uploaded. So, and then I'm going to use that in the next part of the demo. So it's just finishing now. So it's a real nice graphical representation of something that's running in a pipeline. So a true ML ops. So we're now going to look into the Mini.io UI, and we'll do a refresh on that, and we'll see some new data that's just been uploaded, and I'm going to use that data later on. So I'm just going to take a cut and paste of that. So I've been told to rush up because there's only 5 minutes left. From here, I'm not able to move the demo forward, so sorry about that. So this part here, we are now going to take the output of that run, that model, and I'm literally going to go through this notebook, and where you can see the bit in red, I'm just going to cut and paste that S3 data, and I'm going to use that to offline score and run another model against it. Okay? Ultimately, what we want to get to is that we'll run this, and then on the output of it is going to be some real data. So as a consumer, if I want to then query that data and query the spreadsheet to see if it's fraudulent or not, I will get an HTTP or an endpoint, and I'll just be able to consume it if I need to find out if it's fraudulent or not. So I think this has got maybe another couple of minutes to go. So do we want to end it there and let Andy finish off on the last slide?
Keep going.
Okay. Okay. So what I've done now is I'm running another pipeline, but essentially now what I've done, I've stitched two pipelines together. So the first one, which we did processing, and now I'm going to use this new model that we did on the offline scoring, and we're going to stitch them together to produce an output that then, on the last piece of the demo, I will be able to bring up a model server, so I can have as many model servers, again, for performance. So I have this model server that I can run against the data again to see if the data is fraudulent or not. So we've got some new data, which is just now CSV file. So we turned it from some Parquet data into CSV file, and we're going to use that data at the very end of the demo, which will be soon. And this is going back into the OpenShift Data Science console. And you can see we've had some various pipeline runs. So we've seen that some that have failed. So as a data scientist, I can see why it's failed and go into it. And we're going to create a new pipeline now. And again, it's just a few clicks. And this is serverless. So underneath, inside OpenShift, it will actually fire up the container. And essentially what I will get is an endpoint. And that endpoint I can then plug into my last part of the Jupyter Notebooks. And I will then to run some data against that to see the output. So this is the last stage now. So we're going to go back into our Jupyter Notebook. As a data scientist, I now pick my other Jupyter Notebook that I've done some pre-work on, and I literally just put in that endpoint, and I will run that through, and the green lines there is just some random data that I've picked out in the fraudulent credit card, and it just comes back and says, in this particular case, I've not found any data that's fraudulent. So a real end-to-end, what we were talking about at the very beginning with, getting the data, deploying or modeling the data, and then deploying it. So this is the end of the demo. This is essentially just going back over what we've been doing. And with that, I will hand over to Andy.
So I don't know how we are for time, but I guess the conclusion of this kind of presentation is that by using Starburst, we're able to massively reduce the time spent discovering data, finding data that's relevant to the question we're trying to answer. And so our data scientists can now spend more time in the Red Hat OpenShift data science tool on building those models. And then, as Keith described, once we've built those models, we can deploy them. And he described deploying them both into kind of a batch process where we're storing large volumes of data, or we are executing that model based on new records as they come in, which he showed kind of right at the end. So I guess the takeaway here is that the combination of those two technologies allows us to be more effective as data scientists and more efficient as data scientists. Hopefully, by spending more time in the model development phase, we're able to build better quality models, which allow us to better predict or better understand the behaviors of our customers, or the behaviors of the fraudsters, or just whatever it is that we're looking to predict overall. And I guess with that, we will finish the presentation. I don't think we've got time for anything else. Have we got time for questions? No. Okay, right, we're finishing the presentation there. Thank you very much.